Section 7, Taking Turns. Now that we have a game structure, we need to focus on how the game is played. In this section, we'll start by modeling the player's trays. That is, the player's hand where they hold the letters that they can use. Next, we'll look at validating the player's turn, ensuring that it meets our rules. And finally, we'll store the player's turns as part of the game. This is video 7.1, the player's trays. Now this video will break down the modeling of players' trays and how they will play the letters that they've been dealt. We'll look at how we create and refill a tray after the player plays the letters and how to determine that the letters from the tray are appropriate to form a given word. So to get to the meat of what needs to be done for this to work, let's break down a player's turn step by step. Now when the game starts, all the players are given a tray with 7 tiles. Each player looks at the letters in their tray and determines what word, in combination with the first and last letter of the previously played word, they can make, and decides to play that word. The word is checked against the dictionary and determined to be valid or not. If valid, the word is played. The tray is refilled to 7 tiles if possible, and play is passed to the next player. So let's throw out all the stuff that doesn't directly affect the tray. We're left with the following requirements. 1. The tray starts with and attempts to maintain 7 letters. 2. The tray must determine if a set of letters for a word exists in the tray. And 3. The tray's letters may be ordered by the player. Actually, so I just added that last one because I've played games like this and I know that players like to arrange and rearrange their letters as they attempt to form words. So we'll just call that one a user experience requirement, even though we aren't going to code that part in the video. Still, that last requirement is what forces us to use a list instead of a set, and that makes our task just slightly more difficult. Now, as usual, before we begin, we're going to check out the appropriate section, which we are in 7.1. We should go ahead and run our tests. So let's run test 7.1 and verify that we are indeed failing our tests. And we can see there the things that we'll need to do. Now let's open up tray. So the first thing we're going to do is create a tray. And, frankly, this actually couldn't be easier. Why? Because we're just going to delegate all the work to the refill tray method. After all, creating a tray is really the same thing as refilling a tray. That is, it pulls enough tiles from the tile bag to have a total of 7 in the list. So let's just do that. Let's just call refill tray, which I already have elsewhere. And we need to give it the same parameters that we had. And then we're done with that. Unfortunately, that won't fix any of our tests for us, but we'll pick up that function in just a minute. So now let's take a look at the play letters function here. This is the function that will drive the rest of the functionality of the tray. So now when a user chooses a set of letters to play, this function will be called. And as you can see, the first thing it needs to do is get the list of letters the player has from Redis. Here. So we're going to write that function next. But once it has the letters, it can call canPlayLetters to check that the letters played are a subset of the letters retrieved. And it does that here. So if that's correct, we attempt to remove all the letters from the player's tray. Here, and you see we're doing a remove here, a list remove. Now you have to note that this is done using the Redis multi command here, what that does is just allows us to run multiple commands in the same transaction, so we can do it all at once. But then finally, after we execute that, we want to do the refill tray, the same function that we just talked about. So let's go ahead and write that getLetters function that we need. So this function just needs to return the letters that we have in the tray. Now I've already provided the makeKey method that creates the game:player ID string that we're using. So we just have to call a function using that key to retrieve all the letters in the list. So let's take a look through the list of list commands. Now Redis, you'll notice, doesn't provide a function that returns all the elements in a list anywhere. This is crazy, right? Well, maybe not, because depending on the application, that could be a very large list of items that would be an expensive set to retrieve. Instead, Redis provides a function called lrange that allows us to retrieve a list of items. Notice that lrange takes three parameters. It takes the key, the start position, and the end position. Now, we want all the letters in our tray, so we'll specify 0 to start and max tiles, which is 7, as the end. So let's do that here. We have our tray key, so we're just going to call Redis lrange tray key 0, max tiles, and return it to the caller. Okay. So while we skipped doing this work while writing the createTray function, we knew we'd have to come back to the refillTray function for it to work, and now's the time. What we need to do here should be pretty obvious though. We need to calculate the number of tiles that we need and then draw them from the tile bag. We'll then take those letters and we'll add them to our tray. So let's do it. Let's go back to our tray.js. In the refillTray function here. Now the first thing we need to do, as always, we'll create the Redis key for our tray, and that's already here. It's called tray key. So now we want to find the length of the tray as it is right now, so we can calculate how many tiles we'll need to draw and replenish the tray from. So let's do that. Let's call Redis list length ln tray key. And this function is going to return our length to us. Now, as usual, we want to get rid of any errors that occur, return those to our caller. Now, I'm going to call this demand. Demand is basically the max number of tiles that we can have in our tray minus the length that we already have. And that will tell us how many we need. Now, if our demand is less than 1, we're basically going to get out. And what we're going to do is return an empty list of tiles to our caller. Basically, that's for testing, so that I can tell how many tiles were actually drawn. Now, we're going to go to the tile bag. We need to draw the tiles that we want. We're going to pass in game ID. We're going to pass in demand, telling it how many tiles to draw. And then it is going to return those tiles to us. As usual, you know what comes next. Turn those errors. Now we have the tiles, and the natural thing that we have to do is put them in the tray. So we're going to call the Redis lpush, list push. We're going to give it the tray key. We're going to give it the tiles that we want to push on there. And we're returning to the client. And that's basically it. So save that. Now we should be able to run our command to test. We get all 4 tests passing, which is fantastic. If you don't, once again, be sure to work through the errors before continuing so you understand what's going on. So, great job. Next up, we'll process and validate a player's turn.